A piece of machinery is to be made from a closed cylinder of height 36 meters and radius 14 meters. For that purpose, 7 conical holes of radius 2 meter and height 1.5 meter and 1 hemispherical hole of radius 3.5 meter are drilled in each base of the cylinder. Find the percentage increase in the total surface area of the cylinder due to these modifications. Understand the question properly. A piece of machinery is to be made from a closed cylinder. So there is a closed cylinder that we have, height of which is 36 meters and the radius is 14 meters. For that purpose, 7 conical holes of radius 2 meters and height 1.5 meters. You understand what a conical hole? A hole is like a simple hole, but a conical hole will be in the shape of a cone. So 7 conical holes, count is 7, right? 7 such holes of radius 2 meter and height 1.5 meter are made. And 1 hemispherical hole. What is a hemispherical hole? Hemisphere is half of a sphere, right? It's like half sphere. So 1 hemispherical hole of radius 3.5 meter are drilled in each base of the cylinder. See, the cylinder will have 2 bases, right? On each base of the cylinder, 7 conical holes and 1 hemispherical hole are made. Dimensions have been given to us. What we have to find out here is the percentage increase in the total surface area of the cylinder due to these modifications. What will be the percentage increase in the total surface area of the cylinder due to these modifications? So I think a very interesting question. It can be asked in both bank or SSC exams, right? So let's discuss the solution now. Important points to be noted. We are trying to make a piece of machinery from a closed cylinder. So there is a cylinder that we have. Originally we have a cylinder, height is 36 meters and the radius is 14 meters. Now for that purpose, which purpose? For this purpose of making the machinery, right? The purpose is to make a machinery. We have made 7 conical holes. 7 conical holes. The radius is 2 meters, height is 1.5 meter. And we have made 1 hemispherical hole. The radius is 3.5 meter. On each base of the cylinder. Important, each base on both the sides of the cylinder. We have to find the percentage increase in the total surface area of the cylinder due to these modifications. What will be the percentage increase in the total surface area due to this modifications? What modifications? Modifications are nothing but the 7 conical holes and the hemispherical hole that we have made, right? Now you've got to understand one thing. I mean, I'll probably draw a lot of diagrams for you to make the explanation clear, and then the calculation part needs to be done. I'm very clear that this is not going to be a very easy one to solve if you find it difficult to visualize the diagram, right? So try to focus on that. We have got a cylinder. We've got a cylinder. This is a cylinder. The height is 36 meters. Height here is 36 meters, right? Height is 36 meters and the radius is 14 meters. The radius is 14 meters. So here's the radius, let's say. The radius is 14 meters. Right? So we've been given the height and radius of the cylinder. Now, so we are trying to make a machinery out of this. We are making a piece of machinery from this. For that purpose, we are making conical holes. Now understand, the question is about total surface area. What do you mean by total surface area? Total surface area of a cylinder. Now, if I have to find out the total surface area of the cylinder, what is total surface area of a cylinder? See, sum of the surface area of the base plus this base plus the lateral surface area. This is like a circular box, right? So total surface area for the cylinder would be what? Total surface area for the cylinder is 2 pi r square plus 2 pi rh. I mean, I'm not getting into the basics of why this is the formula. All that has been discussed. Let us just understand that the formula is 2 pi r into r plus h. The total surface area is 2 pi r into r plus h, where r and h have been given to us, 36 and 14. So we have to find out how much will this total surface area increase if some modifications are done. Now, what are the modifications we are doing? We are making conical holes and hemispherical hole on each base. So let's take this. This is the base, right? This is the base of the circle. So I'm going to show you a larger view of the base now, right? I'm just trying to draw a larger base so that you understand. So let's say this is the base. I mean, this is the same cylinder with a bigger this thing so that I can explain to you. Now, on this base, on top, there is a base, right? We are making conical holes. Now, how will a conical hole look like? You know what a cone looks like, right? A cone is like this. A conical hole will be like this. how will a hemispherical hole look like? Hemispherical hole. You understand? So basically, if I go and check the top of this top view, try to look at the top view, right? From top, if you try to check the cylinder, right, you will find that there are 7 such conical holes. So which means there will be a hole like this here, and inside the hole the shape is going to be like that of a cone. You understand? 7 such holes. I mean 4, 5, 6, 7, let's say. And then there will be only one, right? 7 and 1 hemispherical hole. So there will be like a hole here, and when you look at it, inside it will be like a hemisphere. You understand? So when you look at, so total there are 8 holes. Altogether there will be 8 holes. Altogether there are going to be 8 holes, 7 of which will be conical, and 1 is going to be a hemisphere or a semisphere, whatever you call it, right? You understand? So this is like these circles that you see on top, right? This will perfectly map with the what is this called, the base of the cylinder. The inside of that will be like this. So if I actually have to show you the top view, it is going to be like this. The top view will be like this. Let's say the top view. I mean, this is top view, and this was not the top view actually. This was the front view, right? Strictly speaking, what I showed you there was the front view. I am doing all this drama because unless you understand the diagram, you cannot solve this, right? So that is the reason I am drawing all these diagrams. But I could visualize it, and if I can visualize, then I will be able to solve easily. So this is the top view. This is the top view. So this is like the base of the cylinder, this base. For this one, I'm showing the top view, right? This is the base of the cylinder, right? So on that top view, if you see, there will be 8 holes. Right? And inside of this hole, I mean, when you try to visualize, 7 will be like in conical shape. And 1 will be like a hemisphere. You getting it? So this is like drilled inside, right? Drilled inside. Now the question was, when you are removing something, how will there be an increase? He's asking us to find out the percentage increase in the total surface area. How will it increase? Find the increase in the total surface area of the cylinder. See, why will the total surface area increase? You have actually made holes. See, total surface area of the cylinder, when you said 2 pi r square plus 2 pi r h. What is this 2 pi r square? Pi r square is the base. Pi r square here is another base. It's like a circle, right? This circle. So area of the circle is pi r square. So 2 such circles. So 2 pi r square. Plus area of this lateral surface is 2 pi r h. You're making holes on these surfaces. When you're making holes, the area will come down. But he's asking us to find out the increase in the total surface area. Why will the area increase? Try and understand. The area will increase because while this top portion gets eliminated, inside you will get some more area. See, total surface area, that will also become like a surface. You understand? It will become like a surface. It is like deep inside, and that's like surface, right? You can pour something inside that. You understand? So while these circles will cut out, I mean, I'll show you in red. What I'm showing you in red will cut out. You know, these are removed. All these things are removed. All these 7 are removed. So minus that. But what is getting added? What I'm going to show you in green is getting added. This is getting added. A hole is actually making a circle on the surface, but in the process it is adding something on the surface. What is it adding? It is adding these green sections. You understand? This will be the hole. The top part will be the hole. So there's green things. You're able to follow? See, try to visualize this one. This green is getting added. Similarly, this green is getting added. What is getting removed is the red thing there again. This will be removed from the total surface area of the cylinder. But in that removal, this will get added. And if you observe, what is actually getting added here is nothing but the what is getting added here. If you observe, this green section here is the lateral surface area of the cone. This is getting added. This is the addition. And this is the LSA of the hemisphere. You're able to follow. So to the total surface area, to the total surface area of the cylinder, which is this 2 pi r square plus 2 pi r h, or 2 pi r into r plus h, we have to, from that we'll have to remove these reds and we'll have to add these greens. So the greens are lateral surface area of the cone and the lateral surface area of the hemisphere. What is removed? The reds. The reds are nothing but the this is like circle. All the reds are like circle. This is like circle, base of hemisphere, and this also like base of hemisphere. Base of the base of what? This is a cone. So these things have to be removed and those have to be added. You understand? I mean, what all I've done on paper so far is just the visualization of the diagram. You are not going to spend so much time in the exam. You will not be drawing these diagrams, right? I mean, if you can visualize, then you can start doing the calculations. Are you able to follow? If you can visualize, then you will be able to do the calculations easily. So all that needs to be done to arrive at the final answer. Of course, if options were given, maybe some approximation we could have done, approximate calculation could have been done, but since options are not given, we'll have to do the complete calculation. So now I will start the real solution. I mean, this is just the understanding of the diagram there. I'll start the real solution. And also remember that this thing, whatever we have discussed, will happen on both the sides, on both the bases, on the top as well as at the bottom of the cylinder, right? On each base, he said. On each base, this has to be done. So what we will do now is, let us find out the change in the area. How much is the change in the area? So what will we remove? From the total surface area of the cylinder, we'll remove these things. All the reds will be removed. It will become like a gap there, right? So that has to be subtracted. What will get added is the green portion. What will get added is the green portion. You're able to follow? You know, you have to imagine, easier way to imagine this is like, let's assume there is a cube. I mean, I'm just explaining you how to imagine, right? Let's assume there is a cube. This is a cube, let's say. Well, it doesn't look like one, let's assume, right? Imagine that is like cube. Now from this cube, from one of the corners, a smaller cube is cut off. A smaller cube is cut off. So let me show you what happens. Let's assume we have cut off a cube, a smaller cube from the corner. You understand? This cube has been cut off. So basically you cut it off. This section, I mean, this shaded portion is cut off. Doesn't mean that when you have cut it off, the total surface area will reduce. The total surface area may increase also. Because if you imagine what happens after that, the cube will become like this. I mean, I'll just clear that, erase that. Oh, this is the problem. I have erased the whole thing. But yeah, how will it look like? Just try and understand after that removal. It was like this, right? It will have a gap now. I mean, this is the original cube, let's say. It will become like this. I mean, it's hard to draw. I think I should not try out my drawing skills here. But the point is, yeah, if you visualize, it is something like this. You understand? So this is like a cut. This has been cut out. While this has been cut out, inside it will form more surfaces. The moment it forms more surfaces, you will get more surface area, right? So let me clear this and solve this question now. So basically, if you have understood the overall diagram now, all we need to do is, from this total surface area, we have to subtract what? We have to subtract all those 7 bases of cones and 1 base of hemisphere. In fact, we'll have to double it because it is being done on 2 sides, right? So simple calculation is that, you know, this is the real original, right? Original area. How much will that be? Shall I clear this diagram now? I think now that you've understood, let me clear the diagram because sorry, where is it gone? Just a second. Yeah, I think I'll clear the diagram now because this space anyway won't be sufficient. So I'm just clearing this part. Okay, let me use this space to do the calculation. So here's the new surface area, new total surface area of the cylinder. Or let me directly find out the change. That will help us, right? Instead of finding out the new total surface area, see, he's asking us to find out the percentage increase. Percentage increase is nothing but increment divided by original value. Original value is this. This is the original total surface area. Original total surface area. Let me do the calculation by the way here. So this will be 2 into 22 by 7 into original radius is how much? 14 into r plus h, 14 plus 36. So 7 goes 2 times here. 2 into 22, 44 into 2, 88. 88 into 14 plus 36 is 50. Let's keep it as 88 into 50. Maybe these kind of common values will be there in this change also. We can do this. So this is whatever cubic units. No, sorry, square units. Right? At least conversions are not needed because everything is given in meters. Now let us find out the change. Instead of finding out the new total surface area, let me find out the change. That will help us get the answer faster, because new total surface area would only mean original surface area minus the plus or minus the changes, right? So let's find out the change in the surface area. So change in the total surface area, right? What are we going to do? Plus 14 LSAs of cone plus 2 LSAs of hemispheres minus 14 bases of cone minus 2 bases of hemisphere. Why all this? Why 14? Because see, 7 on each side, each base, 7 into 2, 14. So 14 lateral surface areas of cone and one hemispherical hole on each side, right? So it becomes 2. So 2 lateral surface area of hemisphere. That's what it will, right? Red parts are removed. So bases of cone, bases of hemisphere are to be removed. So 14 bases of cone, 2 bases of hemisphere to be removed. Greens are added. Lateral surface area of cone and lateral surface area of hemisphere are to be added. Right? I think done. Now it's only about calculation. Now it's just about calculation. This is the base of the hemisphere. Okay, so let me do the calculation. This change will be equal to what? I think again I have eaten up too much of space here, but let me do the change directly. So change will be equal to 14 lateral surface area of a cone, right? Lateral surface area of a cone is how much? Pi RL. I'm not discussing all the formula and all. I'm sure you know the formula, right? Lateral surface area of a cone will be, I think, pi RL, yeah? Pi RL. So pi into R. So pi is 22 by 7 into radius of cone. So what is the radius of the cone given here? 2 into pi RL. Now understand, L in a cone is what? The slant length of a cone is root over R square plus H square. So it will be root over R is how much? 2 square plus H is 1.5 square. How much will this be? I mean, these are the changes that we have to do, right? What is this value? This is another box. I mean, pieces of calculations that we are doing. So 2 square 4, 1.5 square is 2.25. 4 plus 2.25, 6.25. Square root of 6.25 is 2.5, right? 2.5. So this comes out to be 2.5. Yeah, this is equal to 2.5. So 14 times of 14 lateral surface area, right? 14 into pi RL, pi into R into L. L is 2.5 plus. So this is one portion plus 2 lateral surface area of hemisphere. What is lateral surface area of hemisphere? I think, see, total surface area of a hemisphere is, how will you do this? Lateral surface area of a hemisphere is, actually it should be, Oh, am I? Hold on. Let me just visualize this. Are we doing the right thing? Yeah, I think it's right. The point is lateral surface area of hemisphere. What is lateral surface area of hemisphere? 4 pi r square is the total surface area of a sphere. So for a hemisphere, it is going to be half of it. 2 pi r square plus pi r square, 3 pi r square. Yeah, I think you got to understand this thing. We can save some time here. Let me highlight. This 2 lateral surface area of hemisphere plus 2 and minus 2 bases of hemisphere can be calculated like this. I am just showing you the calculation here, right? Look at this. See, lateral surface area of a hemisphere. Where do I do? I don't have space. Lateral surface area of a hemisphere, LSA of a hemisphere is equal to half of 4 pi r square, right? So that will be 2 pi r square plus 1 full circle. So pi r square, 3 pi r square, right? And base of a hemisphere. Base of hemisphere is anyway pi r square, right? Circle, which is equal to pi r square. Now basically you have to do plus 3 pi r square. Since we are adding the lateral surface area and subtracting the base, it will be plus 3 pi r square and this will be minus pi r square. So the total will be what? Plus 3 pi r square minus pi r square will give you what? 2 pi r square for each hemisphere. So 2 times of 2 pi r square. You understand? I'll highlight this. So basically whatever has been highlighted there in yellow, the calculation is here. So we can reduce a few steps. You're able to follow. So for each hemisphere, we should take plus 3 pi r square minus pi r square, which is 2 pi r square. And there are 2 such hemispheres, right? So 2 times of 2 pi r square. So 2 into 22 by 7 into r square. What is radius of this hemisphere? 3.5. I'll highlight this also in yellow so that you can connect all this highlighted part is the calculation. Of course, into square, right? Into 3.5 once again. Sorry about this lengthy solution, but there's no way out. You have to do this. Right? 2 into this calculation, 2 pi r square. Two pi r square. Yeah. So done. And minus 14 bases of cone. Minus 14 bases of cone. What is base of a cone? Pi r square, of course. So minus 14 into pi, 22 by 7 into r square. What is radius of the cone? Radius of the cone is given as what is the radius of the cone? Sorry, conical hole radius is 2. Yeah, radius of the cone is 2. 14 bases, right? So 14 pi r square. Pi r square. 2 into 2. I'll do one thing. I'll use some other highlighters also so that you understand what portion is what. Let me use a purple color. So 14, I don't know how the color would change. 14 LSAs of the cone. That calculation is this. I should have used a lighter color. I'm sorry about this, but yeah. And then 14 bases of the cone. Yeah, let me use this. 14 bases of the cone. That calculation is this. So these 3 things have to be taken care of. Finally, now do this calculation here. I think. So what happens here? This is equal to overall. 7 gets cancelled twice. Here also 7. I think 2 into 3.5 is 7. So this and this gets cancelled. And here 7 goes twice. So we have, what is this first part? 2 into 22 into 2. 2 into 22, 44 into 2, 88. 88 into 2.5. plus, right, how much is this? 2 into 22, 44. 44 into 3.5. Minus, how much is this? 2 into 22, 44. 44 into 2, 88. 88 into 2. Yeah. So here's the change. This is the change. Now do that calculation. So I think this can be taken as, I mean, if you take 44 common here, 44 into 5, yes or no? I'm doing the calculation mentally because I don't have space. I'll write the final value here, right? I think better I write final value in terms of 88. Let's see, 88 or 44 at least. So this is like 44 into 2 into 2.5. So 44 into 5 plus 44 into 3.5. That will give you 44 into 8.5 minus 44 into 4, right? I repeat, 88 into 2.5 is 44 into 5 plus 44 into 3.5. 44 into 5 plus 44 into 3.5 is 44 into 8.5 minus, this is 44 into 4. So 44, if you take common, 8.5 minus 4, 4.5. So 44 into 4.5. Final is going to be 44 into 4.5. That's it. So this is the change finally. Let me highlight this also so that you can understand overall. Which color should I use? I don't have enough choices here, but let me try this. So the change in the total surface area is equal to 44 into 4.5. Now what is he asking us to find out finally? The last step. Find out the percentage increase in the total surface area. So percentage increase in the total surface area is this. See, we've got a positive value. That means the total surface area has actually increased, right? So 44 into 4.5 is the increment. So percentage increases increment by original value. Original value is 88 into 50. So 44 into 4.5 divided by 88 into 50 into 100. X is what percent of y? X by y into 100. Or percentage change, right? Percentage change is change by initial value into 100. Change by initial value into 100. So what I'll do is I'll erase one more section here so that I can explain this to you, right? I'm clearing this diagram, right? This diagram, or maybe I can clear this diagram. Final step I can do here because this is just a regular cylinder. Chalo, so finally the last step, I think, right? Percentage change will be equal to change by original in 100. So what is the change? 44 into 4.5. Divided by original 88 into 50. Into 100. So do the calculation now. I think 44 goes 2 times. 2 into 50 gets cancelled with 100. We are left with 4.5%. I think that's the final answer. 4.5%. So the change in the surface area because of all this drama that we have done comes out to be 4.5%.